Hello, Algebra students. We're ready for Section 4 of Chapter 3. I'm going to ask you to do the two review problems here on your own, and we will check those together in class. And I'm going to move on into the new vocabulary from Section 4, starting with the term direct variation. All right, we've already talked about having a constant rate of change, and this lesson is going to talk about direct variation, where you have an equation y equals kx. Now, k in this equation cannot be 0. If k is 0, then you have y equals a number or y equals 0. So it would not be a direct variation problem if k was 0. And x and y in direct variation problems, they either both go up or both go down. You'll hear the language y varies directly as x. Okay, that's their relationship. Varies directly, direct variation. Y varies directly as x. All right, and k in this problem, we used to call k the slope, and we still will from time to time, but for these problems we call that the constant of variation, the proportion at which we change. Okay, it's also known as constant of proportionality. Okay, so the slope of the line is its constant of variation, how it's going to change, how y varies directly to x. All right, so here is a summary. I've already written on it. Let me go back and say this again. Direct variation equations are in the form y equals kx. You'll notice there's not a plus b. There's not a slope-intercept. In slope-intercept form, there's no y-intercept. K cannot be 0. You can't have a slope of 0. If you do, it's not a direct variation problem. All right, and it's always going to pass through the origin. That's why there's no y-intercept. The y-intercept is understood in y equals kx. It's understood that the y-intercept is 0. So you either have a positive slope or a negative slope. They will always pass through the origin. The y-intercept will always be at 0, 0, the origin. Okay, at the top of the next page, we're going to talk about slope and constant variation, which ultimately are talking about the same thing. So if we're looking for k, how is this line changing? Well, every time it rises 2, it runs 1. Rises 2, runs 1. If you rise negative 2, you run negative 1. Well, negative 2 over negative 1 is still going to give us 2 understood over 1. So the constant of variation, I'm going to write it out this time, but from now on I'm going to refer to it as k, is equal to 2. Then it said also find the slope. Well, if we found the rise over the run, we have found the slope. The slope, which is m, I'm going to use m from now on, slope is also 2. If you don't trust me, you can do the equation, the change in y over the change in x, and 2 minus 0 over 1 minus 0 is going to give us 2. All right, so if you need to check yourself, feel free to do that. So in B, what is the constant of variation? I see here it's going to be negative, so check yourself. Oh, and they gave us the equation of the line. Excuse me, I didn't even pay attention here. We have it right there. Y equals kx. K is the coefficient of x. So k was 2. I didn't even have to take the time to do the slope formula. I wasn't paying attention to my picture. All right, so what is k here? K is negative 4. What is my slope here? My slope is negative 4. So constant rate of change, constant variation, and slope mean the same thing. So if I graph you can graph both of these on the same line. Both should pass through 0, 0 because there is no number for our y-intercept. So I'm going to rise 2 and run 1. So my k here is 2. My slope is rise over run. So it's 2 over 1. So I'll rise 2, run 1, rise 2, run 1. There's 2 points. Let's go -2, -1. That's still equal to a positive. Excuse me, I don't do it from there. Even I make mistakes. I should have done it from 0, 0, down 2 to the left 1, and there's my line for the first equation. And if you have the liberty of using colored pens or pencils, change colors and let's graph the other one. Passes through 0, 0. This is the same thing as -3 over 4, or 3 over a -4. I always put my negative with my numerator. So I'm going to rise -1, 2, 3 and run positive 1, 2, 3, 4. So there's 1 point, 0, 0 is another point, and a third point. I could, like I said, make it positive 3 over -4. So I'd rise up 3 and to the left 1, 2, 3, 4. And that's the graph of the second line. Sorry, I'm not using a straight edge. And they always will pass through the origin. Alright, at the top of the next page, we're going to write and solve direct variation equations. Suppose y varies directly as x. So we're looking for the form y equals kx. Y varies directly as x, and y is 9 and x is -3. So y, in place of y, I'm going to plug in 9, and in place of x, I'm going to plug in -3. So write a direct variation equation that relates x and y. So it says here y varies directly as x, so I need to figure out the constant of variation. I need to figure out k. So I'll divide both sides by -3, and k equals -3. So the solution, or what they're asking me for, the equation here, is y equals -3x. That's my answer because I solved for k. Use the above direct variation equation to find x when y is 15. So in place of y, I'm going to plug in 15. And I'm supposed to find x. So that means divide both sides by -3, and x is going to equal a -5. I'm using the same equation from number 1. Suppose y varies directly as x, and y is 15 when x is 5. So it's a new problem. I'm not using number 1 or number 2. Y varies directly as x. They give me y. Here's the equation we're looking for. Y is 15, x is 5. So that means when I divide both sides by 5, k is going to be 3. So write the direct variation equation, y equals 3x. It's an equation because x and y are going to change constantly. It's linear, and I needed to know the constant rate of change, which was 3, understood over 1. Now use that direct variation equation and find x when y is -45. So y equals 3x, y is -45. Solve for x, divide by 3, and x is going to be a -15. One of the most popular direct variation equations that we have already worked with is distance formula. Distance equals rate times time. That is a direct variation equation where the rate stands for the k, the constant rate of change, the constant of variation. So the Ramirez family is driving cross-country on vacation. They drive 330 miles in 5.5 hours. So that's our distance, that's our d, and this is our t, our time in hours. Write a direct variation equation to find the distance driven for any number of hours. Okay, so I need to know k. I need to know r, their rate, their constant rate of change. So I'm going to take that equation, I'm going to plug in for d, 330 equals r times, and the original time I was given was 5.5. So I'm going to divide by 5.5, and my k here, which is the same thing as r, is going to be 60 miles per hour is our rate, or our constant variation, k. So it asked us then to write a direct variation equation. My direct variation equation is going to be distance equals 60 times t. And it says estimate how, that's my equation. So that's the actual answer to the problem, because it says write a direct variation equation for any number of hours, how far they will travel. And I needed first to find my r. So I used this to get the answer, d equals 60t. Now, estimate how many hours it would take for them to drive 500 miles. So if they're driving a distance of 500 at a rate of 60, at a what? A rate, a change. The constant variation is 60. How long will that take? When you divide both sides by 60, it is going to take 8 1/3 hours, because 6 does not go into 50 evenly. And that would be your final answer to the question. All right, on the back, there's some that I want you to try on your own. I know that you're going to, go back and look back through your notes as you attempt these problems, but let's check your progress. So I'll be looking to see who had the guts to try. That's all I'm asking. It's not an accuracy grade, it's a completion grade. So please try numbers 1 and 2 on the back for your own progress. Here's a little verse to leave you with, and I also have a riddle. If 2 is company and 3 is a crowd, what is 4 and 5? 2's company, 3's a crowd. What is 4 and 5? I'll be eager to hear your answers tomorrow. Have a great day.